Hello, everybody. My name is Sanjeev. Today, my topic is ensuring IT infrastructure reliability through reverse monitoring and alerting. So, this slide is about introduction, what is monitoring, what is alerting. So, let's begin by understanding why monitoring and alerting are essential to system reliability in the cloud. In today's fast-moving digital infrastructure, cloud system handle huge amount of dynamic workload. Any small issue like high latency, memory spikes can quickly snowball into service disruption. That's where monitoring and alerting step in. Monitoring tool give us a real-time visibility into system health, metric like CPU usage, latency, and throw output allow us to detect problem easily. Actionable alerting is just as important. It is not enough to get notified. Alerts must be meaningful, targeted, and free from noise. This helps avoid alert fatigue, which happens when team gets overwhelmed with non-critical alerts and start ignoring them. As the research showed, integrating reverse tools like Datadog, New Relic reduced downtime approximately 50% while improving resource utilization. Ultimately, this translates into greater system stability, fastest incident response, and better experience for the users. Why monitor matters? Now let's talk about why monitoring is critical in today's cloud environment. Cloud platforms like AWS, Azure, and Google Cloud have made it incredibly easy to scale application, but that flexibility comes complexity services are spread across regions, API microservices, containers, and sometimes even across hybrid or multi-cloud setup. In such dynamic system, things can go wrong fast. You might see unexpected latency, intermittent failure, or even complete outage. And often, without a monitoring system in place, you wouldn't know until user start complaining. Monitoring tool acts as a eyes and ears. They continuously track performance, indication, and system health in real time. Without this layer of observability, you are essentially flying blind. You are reacting after the fact rather than proactivity solving issue. In essence, monitoring shifts your approach from being a reach to preventative. It's become your early warning system, helping to maintain system reliability, performance, and trust. So, what are the tools in action? Let's look at the tools that bring monitoring to life in real world environment. I have evaluated three popular monitoring tools, that is Prometheus, an open source metric based monitoring tool great for containerized environment like Kubernetes. Number two is Datadog, a commercial SaaS solution that integrate well across cloud service and provides powerful dashboard and alerts. And number three is like New Relic, known for application performance monitoring, real-time observability, and user experience tracking. These tools were tested across three major cloud platforms, that is AWS, Azure, Google Cloud. In addition to simulated environments, they were deployed in a real-world health insurance company using Microsoft Azure. This added practical depth testing how these tools perform under actual workload such as high traffic during claim processing and compliance-driven application. The goal was to understand their impact on latency, resource usage, throughput, and cost, and most importantly, how they help detect and resolve issue easily. How they help detect resolve is easily. This hands-on deployment gave us valuable insight into the strength and trade-off each tool in both test and production environments. Now let's talk about the essential factor to monitor. Essential factor to monitor, one is latency, throughput, CPU and memory usage, and operation cost. Let's go one by one. When it comes to the monitoring, knowing what to measure is just as important as having the right tools. Let's walk through the 4 essential factors that need to be tracked. Number 1, latency. Latency. This measures the time it takes for a system to respond to a request. High latency can frustrate user and signal system slow down or backend issue. Throughput. This is how many requests or transactions your system can handle per second. A high throughput means better stability and more efficiency resource utilization. CPU and memory uses. Monitoring these tells you how your infrastructure is being used. Spikes many indicates performance bottleneck or inefficient application. Operation cost, that is also one factor. Other overlooked but critical, monitoring itself use resources and some tools incur additional costs. You need to track this to ensure that the benefit of monitoring overweights the expense. These metrics together give you a comprehensive view of system health. They help identify patterns, bottlenecks, and opportunity to improve performance before user affected. Now let's see what was outcomes from using those tools, monitoring tools. That is real world impact. What is the impact for it? Now let's look at the real world impact. These monitoring tools had across different cloud platforms. After integrating tools like Datadog and New Relic, measurable improvement were observed on AWS. Latency dropped from 100 ms to 80 milli per second. On oil as throughput increased from 1900 to 2400 requests per second. Across all platforms, overall downtime was reduced by around 15%. These numbers might seem small at first, but in cloud environment, especially with high traffic or mission critical application, even a few milliseconds of latency or a few percentage point of uptime can make a huge difference in user experience and business opportunities. This shows how effective monitoring tool doesn't just provide visibility, it's actively help you optimize performance, scale smarter, and deliver a more reliable service or users. These kinds of performance gain also build trust and with stakeholders, especially in regulated environment like healthcare, finance, where downtime and delay can have serious consequences. Let's talk now trade-off and overheads. With monitoring clearly boosts system performance and reliability, it is important to understand that it comes with trade-offs. First, there is a CPU usage overhead. In the study, CPU usage increased by 5 to 8% across platform after integrating monitoring tools. That's because of these tools collect, analyze, and sometimes visualize vast amount of data in real time. Second, we saw a rise of operation cost around 12% on average. This includes the cost of the tools themselves and the extra cloud resources needed to run them. These overhead are not necessarily bad, but they need to be managed smartly. For instance, avoid full stack monitoring if only application level insights are needed. Tune data collection intervals. Do you need metrics every second or every 5 minutes is enough? We need to think on that as well. Monitoring the most critical KPI instead of tracking everything. The key takeaway here is that the monitoring should be strategic when done the benefit for the cost, but blindly enabling all features can lead to the resource waste and unexpected bill. Now let's talk about the preventing alert. So one of the most common challenges monitoring is alerting fatigue. When teams are bombarded with so many alerts that they start ignoring them, even the critical ones. To prevent this, we need to actionable and intelligent alerting, not just noise. Start by defining a smart threshold. For example, don't alert when CPU usage goes above 50%. Alert when it says above 90% for a sustained period. Second, use dynamic baselines. Tools like Datadog and Neuralink can learn what normal looks like and alert only when behavior deviates significantly. Group related alerts together using alert correlation. So teams see the bigger picture rather than isolated symptoms. Most importantly, make sure alerts are routed to the right team with proper context so responder know exactly what action to take. By doing this, you keep your team focused on meaningful incidents, reduced burnout, and respond to real problem faster. In short, effectively alerting should be guide, not overwhelm. What may be the best practices? Now let's bring all together with some best practices for effective monitoring and alerting. Choose the right tool for your environment. Not every tool fits every use case. For example, this is ideal for the Kubernetes environment with Datadog, while Datadog shines in hybrid cloud setup with strong integration needs. Continuously evaluate the cost benefit trade off. Monitoring should be enhance reliability, not drain resources. Monitoring what matter most and fine tune data collection frequency to avoid overconsumption. Focus on actionable KPIs. Track metrics that directly impact user experience and system health. Latency, error rates, through output, etc. Avoid getting lost of vanity metrics. Integration alerting into the incident response workflow. Use tool like PagerDuty, Slack, or ServiceNow to automatically notify the right team. Enrich alerts with context and speed up resolution. Review and refine alert regularly. System evolve. What was critical 6 months ago might not be today. Keep alert up to date and align with current performance goal. Following these practices ensure your monitoring setup is efficient, scalable, and responsive. Not just technically sound but also aligned with business needs. Other way and or future scope may be AI driven monitoring. So predict issue before they occur. So it can be achieved by the AI. Use AI to analyze pattern and defect anomalies early, preventing outage and performance drops. Second, optimize performance automatically. Enable self-healing system and dynamic threshold that adjust in real time, reducing the need for manual oversight. Third, reduce cost and resource usage. Implement smart auto scaling, energy efficient workflow placement, and noise reducing alert system to lower operation cost. Now, let's go to the conclusion. So, looking ahead, the future of monitoring is the increasingly being shaped by AI and machine learning. Traditional monitoring relies heavily on predefined threshold and statistics rule, but with AI-driven monitoring, system can learn from historical data, detect complex patterns, and even predict issues before they occur. Imagine being alert not because of CPU just spike, but because the system learned that a specific pattern of memory and disk behavior typically precedes a failure. That is the power of prediction monitoring, predictive monitoring. This approach helps reduce the need for continuous manual monitoring, minimizing alert noise and false positives, optimize resource allocation dynamically based on expected demand. AI can also help with auto remediation, where minor issues are fixed without human intervention, saving time and improving uptime. The next generation of tools will be smarter, more adaptive, and better aligned with evolving complexity of cloud native environment like container and serverless. Organizations that embrace these technology early will gain competitive edge through the higher system resilience and lower operation cost. Thank you for listening me and let me know if you have any question. Thank you.